Section 4.3 is nothing new. It is transforming the absolute value parent function, which we did the first couple days of school. So we're just going to go over it briefly, but you've already done it. So let's go ahead and flip to, let's actually let me give you an overview real quick. Let's say I give you this function. F of x equals, we'll call g of x the parent function, which is this. If you remember, it looks like a v. If you forget, you can always plug in points and plot them. Let's say I have this parent function. Here's what's happening, and it does need to go in a specific order. First, you want to talk about what we call the horizontal translation. Translation means to slide, so this is moving it left or right. And normally we think minus moves it left, but it's actually going to move it right. So you can write this down if you want, but it's just a review, so you don't have to. The second thing you need to look at is this out here. Now, looking at the 3, that's going to be a vertical stretch by a factor of 3. So it's going to stretch 3 times faster up to the ceiling. And then this negative, which you can do first, or you can do the 3 first, it doesn't matter, but the negative reflects it over the x-axis. So either one of those can come in either order. You could do both at the same time if you're comfortable. And finally, this, which moves it up or down, which we call the vertical translation. Remember, translation means to slide. And it's positive, so that means we're going to go up 5. So what you would do, and I'm just going to rough sketch this, you're going to take every point and you're going to do the following things. So you're going to move, let's say I start with this point, I'm going to move it right to vertical stretch by a factor of 3. It currently has a height of 0. 0 times 3 is still 0. Reflected over the x-axis, I'm still at 0. Finally move it up 5. And right there. Then you'll take another point, let's say this blue point. It has a height of 1. So I'm going to move it right to, stretch it by a factor of 3. If its height is 1, I triple that. So now I'm up at 3. And then I move that up 5. I do that for every point until I get my final graph. Okay? And you should be doing that without a calculator. So the book walks you through this, but we've already done this. So for instance, this one, part A is going to move up 1, down 2, stretch it by a factor of 3, reflect it. Moving on to number 3, that's going to talk about the left and right. Don't worry about this for right now. We're going to get to something like that. Let's look at number 7. It says this. Because of the way absolute value works, that's actually going to be the same as if the 2 were outside. It doesn't make any difference for this function. It will for other functions. So if we feel more comfortable, since we didn't really talk about a multiplication on the inside, we can move it to the outside. This would be a vertical stretch by a factor of 2. Or what you'll see today is if it is on the inside, instead of describing it vertically, they might describe it horizontally. So that would be a horizontal shrink, remember, because if it's vertically stretching, it's going to horizontally be shrinking by a factor of 1/2. So try not to let it confuse you. If you see it on the inside, it's usually described as a horizontal stretch or shrink. If it's on the outside, it's usually described as a vertical stretch or shrink. You'll either have one or the other. And your factor will either be 2 or 1/2, 3 1/3, something like that. If I had this, think of what's happening. So if this is my parent function, that's going to be the same as if the 1/3 were on the outside, which means it's vertically stretched by a factor of 1/3. So if this height is 1 right now, 1/3 of 1 is 1/3. This height is at 3, 1/3 of 3 is 1. I'm going to go out to this point, which has a height of 6. 6 times the third is 2. So that would make this function and if I were to describe that 2 different ways, this would be a vertical. Now, is it stretching or shrinking vertically? Is it rising to the ceiling or is it falling? It's falling. So it's a vertical shrink by a factor of a third. Or if it's written like this in your book, sometimes your book, or you're allowed to also describe it horizontally. So horizontally, what is this green graph doing? Is it stretching horizontally to the sides? Yeah, it's getting to the side a lot faster. So horizontal stretch by a factor of 3. These are interchangeable. I just wanted you to be comfortable seeing both. So what I want you to do to review this lesson is to make up your own problems, practice them, go back to the ones that we did at the very beginning. So you might have to look up a new video. You can always just go like this. You can make up your own. So let's say 5x plus 2 minus 4. Go ahead and graph the parent function. Do this first, this second, this third. When you're all done, grab a graphing calculator and see if your graph matches this graph. That's a great way to practice. So that should be really all you need for 4-3 because it's nothing new. We've already done this lesson at the beginning of the year.